Today we're solving problem 20 from the Spring Amc 10B from 2021. The figure is constructed from 11 line segments, each of which have length 2. The area of pentagon ABCDE can be written as the square root of m plus the square root of n, where m and n are positive integers. What is m plus n? So what are we given? Well, we aren't given that this is a normal pentagon. We're given that each line segment here has 2. So like AB is 2, AE is 2, DE is 2, CD is 2, and BC is 2. Now, it's every line segment is 2, and like three of these vertices, B, C, and this unknown point here, all these side lengths have 2, then that means it's an equilateral triangle, therefore that all these angles are going to be 60. This is 60, and this is 60, therefore this is 60. So this entire angle is going to be 120. So it's like, so instead of writing two 60s together, we can write one 120. And this applies for every single part that's like this 120 and such. Now, we have to draw lines to solve this problem. When we draw, so the lines, we only have to draw 2, but they're very crucial to solving this problem. The first line is A to C, and it's going to look roughly like this. A to C. And A to D. This is not accurate, but it just shows that you can do it. Now, we can sort of ditch the 120, and we find out that there's a lot more properties about these triangles. Let's just do 60 and 60 for this one, and then 120 for that whole. Well, we know that this is 2, this is 60. This has to be 30, because this is an equilateral triangle. Cut it from the altitude, this is 30. Therefore, this angle has to be 90. Or right angle. So this is a 30, 60, 90 triangle. And it has some properties. Let's just enlarge this. AED. Without all the other lines going on. This is 2, 2. When we draw that line from the top, this is going to be right angle, 60, and 30 degrees. Now, some of these properties is that we can actually find all these side lengths just from, because this is a 30, 60, 90 triangle. We know, from the properties, we know that this side is root 3 and this is 1. So root 3 and 1. So this entire length is going to be 2 root 3. Now the area of this entire pentagon is, what we can do is add up all the area of these two triangles plus this triangle in the middle. And we solve this one first because we can get the side length for this and use the Pythagorean theorem on the height. So for the area of this one, the height is 1, so 2 root 3 over 2. That's the area of one triangle times 2. Since there's 2 such triangles and they are congruent, these cancel. This is going to be 2 root 3. But since the problem wants it in the square root of m plus the square root of n, this is the square root of 12. Now, we can draw out a CD, this triangle. Since we know that these two side lengths are 2 root 3, because this length corresponds to this length. AD, here I'll just label it AD, E, and then this triangle has lengths AD, see? AD is the same as AD, so 2 root 3, this one's 2 root 3, and this is 2. So when we use the Pythagorean theorem, we cut it in half. Now, it's only going to be 1. And we want to, I'm just going to use x for the unknown height. So this is going to be 1 plus x squared. This is going to be 12. X is equal to the square root of 11. So, so we can sum these two together. So the square root of 11 plus the square root of 12. Because that's essentially the area. So this, we have it in the form like this. We just want to sum up 11 plus 12. This will give us our answer 23. And we are finally done.